here. Where were we? All right. Okay, welcome to this last class of the semester. Program for today is we finish the final exam. I'm going to try to stay focused, not to go into too far a tangent. However interesting it is, but yeah, so it's still relevant. And yeah, and then I think we'll still have time. So I'm going to go into some of the small exercises I posted on Moodle, which I would think are interesting. The one I would like to try is the one of total differentials. So it's, yeah, penultimate one, where you're going to see. Okay, so number 4. What's number 4? Yeah, okay. So we did A, but still let's do it again. So consider function x equals x 12 minus x 4 minus 1. A, find all critical values. So we talked about what we had to do, so I'll just do it briefly. So we take the derivative and set it to 0. So very quickly, it's going to be 4 cubed minus x plus 2/3. So that's minus x plus 2/3. And then we set it to 0. Okay, so what approach should we take from this point on? Yeah, so multiply the polynomial by 3. So that way we don't have any fractions. So let me define something different. So I would have something like y equals to this, but multiplied by 3. X plus 2 equals 0. And then if I give you something like this, there's a decent chance that the roots are, so you're able to find the roots with the way we discussed previously. So let's try and find out. Already? Oh yeah. So okay, but let's imagine that I'm not so smart. And so how did I do that? Yeah, so let's so looks like one assumption, but it's um, so positive numerator. So I will have, so numerators are, yeah, no, so I would, it's, so, yeah, exactly, multiple of questions. I have 1 and 2, positive denominators. Oh, it's just that, because I know that I'm going to have the whole slew of negatives too. Plus, so these two are going to cancel out. So it's just not to waste time. Actually, that's different from the book. This is just, I think it's simpler to do it this way. So just one. So potential. So one is, of course, a divisor of 1 here. So I'm going to get so 1 over 1, 2 over 1, and then other minus signs there. Minus. So yeah, let's try 1. So I would get one equals 2, and this should be 0. Yes. Yeah, actually, we just have 4 to try, so that's so yeah, this doesn't look promising, but just to be sure. Yeah. Let's try -1. And this should be 0. Yes. Spam call every time. They always wait until I'm in class and then go for it. Okay. So doesn't that feel strange? I have 2 roots, -2 and 1, but I have degree 3 polynomial. Exact. So that's the kind of thing. If you have a second order polynomial, so it looks like a parabola this way or that way. So it makes sense that you have like two solutions if I'm nice with you and I give you something with real solutions. So the real rules. And if you have a third order, then you should have three solutions or one. So if you have two, then what's maybe going on is that you may have a duplicated solution, or yeah. So let's see what we're going to get. So um, -2 and 1. So what was the question again? Find all the critical values. So -2 and 1 are, so which are the critical value of f x, which we had, which we wanted to find. So that's A. B. For each critical value, say whether it is a minimum, maximum, or an inflection point. So what should I do?
Check whether the function is so like if it's
Yeah.
you can take the center and see where it's 0. If there's no change of like say it's negative, or positive, then you don't have that.
Yeah. So, but if I have drawn the function, then I can see it. But if I haven't drawn the function, so we have seen an easy test to yeah. Yeah, so the first derivative has to say for a maximum has to be positive and negative. So, but how? So the thing is, the question is, where should I? Yeah. So what you're saying essentially is, I only have to test any point between these. Oh, geez, I had never done it that way. But yeah, I think you're right. That's the only. I just have to check. Okay, that's neat. Yeah, yeah, yeah. Okay, I haven't thought it that way, so I'm not going to introduce new stuff. But yeah, okay, next week, next time, I'm going to maybe do it this way too. So yeah, this would. Oh, okay, I'm not going to be mad at that. On the contrary. So I'm going to tell you how we did it in class. Do you remember how we did it? No? No? So how we did it in class is we check the sign of second derivative at the critical value. So if positive so which should we have? Yeah. So if positive, it means that I have a minimum. And if negative, I have a maximum. And if 0, So I have a minimum, a maximum, or something else. Or inflection point. So I had discussed much more inflection points before, so that's why I have additional questions about it. But I didn't dwell too much on it this time because, yeah, that's. Anyways, we don't really care all that much about inflection points in economics. We should, but yeah. So that's the way we should do it. Okay, so taking the second derivative. So I have that. And then we check. Yes, sorry. Checking critical values. So the first one was -2, and I get -2 -1 equals 3. So that's greater than 0. So what should I have here? Minimum, yes. Then -1 square -1 equals 0. So we don't know, but possibly, yeah, positive, negative, or inflection. And as it's going to turn out, it's an inflection point, but yeah. All right, so that was B. Oh, and then it jumps to D because C, I removed it. So that's moving D. What are the inflection points? So there's only one possibility. It's 1. And to know whether you have an inflection point or not, so this I didn't say it in class, that's why I shouldn't spend too long on it. But to know whether you have an inflection point, you must have the third derivative not be 0. So if the second derivative is 0 and the third derivative is non-zero, you know you have an inflection point. So not covered in class. But for an inflection point, second derivative 0, and the third derivative non-zero. So here we have that. So let's take the third derivative. Equals 2x and at x1, have that equal to 2. So inflection point. Then again, don't worry about this. I haven't covered that in class. Oh yeah, sure. Yeah, that's right. That I only checked. So I should check for all the possible. Yeah, I forgot about that. So yeah, so the second derivative is this. So setting the second derivative to 0. So this equals to 0. So I get x equals plus or minus 1. And then let's try, so at x equals 1, we get an inflection point, and at x equals minus 1, we get minus 2. So another inflection point. All right, so that was D. And then E, draw F. So this, I never do that. I always just go on Google, but that's cheating because you're going to have to do it. So I should place myself in your shoes and try my best. So let's do that as well as possible. Keeping the critical points. So what I'm saying there is the value, the x and y value, or n f of x. At those points. What did I write there? Indicating the critical points and the value of f here at those points. Okay, it was nice. I was being explicit. Okay. So the goal is to, yeah, okay. So I've never really said how you should do that, but the best thing to do is to place all your points. Then you, it's easy to draw the function that links all of them. So trick is put interest, then what points do we care about? So set of points. So we have -2. Yeah, let's put the critical values too. So I'm not going to be mad if you put more information. Just put at least what I said. So -2, -1 is interesting. And then is 0 interesting thing is that what's interesting too is the critical values of f, but I don't know if not the critical value, but the roots of f. I don't know, is 0 a solution for that? 0 minus 0 plus, no, it doesn't work. It's because I get -1, so I don't know what it is. Okay, so let's forget about its x's at 0. So let's just And then I said 1 and 2. Okay, so at -2, f of -2 is, yeah, so let's have f of -2 goes to forget minus. Okay, now -1, 1, and so -1, 1. That's not so nice. Let's just have something. Yeah, that's the thing too. It's hard to always have nice values. So yeah, here it looks like it's not that nice. Minus. This I want 1. So -3/4. And then this one is 2. So of course, bring a calculator, please. -1. Okay. So then the set of points is -2 -1 -25 first. But yeah, I'm going to just use this value there to put it as best as I can. This is -3/4 and -1. Yeah, so mostly negative numbers. Okay, so let's try and go for it. Plus, I know which are minimum and or inflection points, so that that should help us. Okay, so I'm going, the range for x is -2 to +2, so I need, yeah, let's take as much space as, so 1, 2, yeah. This is going to be -2, 1, 0, 1, 2. And I need, so from -3 to, oh, it's all in the negatives somehow. So let's just go to 0. So 1, 2, 3. All right. First point is -2 -3. -1. So however you want to identify, you can just say what point it is, but make sure that you show me that you know what are the coordinates of each point. So I know you understand what you're doing. So that would be one point. Yeah, let's not use gray. Okay, so that's one. And then that one is a minimum. Then -1, and then, yeah. So something like this. +1 and -3/4. So that's -0.75. So it's not here. And then -1/3. Oh yeah. No, I was doing -1.75. Yeah, and then -1/3. So about here. And so that's an inflection point, and that's an inflection point. So what did we? No, what was that one? Oh yeah, that's just an extra point. Okay. So I hope I'm okay. So this is an inflection point. All right. That one is wow, really confused right now. Wow, I'm asking difficult things out of you. Okay, let's buckle up then. So please indicate the values there. So that would be -25 divided by 12. Or you can write the decimal places, but I think it's better to write it this way. This would be -1/4. This would be a bit higher. Okay, so let's draw it by part so I don't mess up. So here, this is a minimum. My this is not the best. Okay, so I know what to do. So I don't know exactly what. So if I wanted to do a better job, I would just at least try to know what this number is there, but I don't know. So here there is no inflection point. So that's section 1. Then what did we say about? So -1 is an inflection point, right? Yeah, -1 is an inflection point. So here it's going that way, and this should be going this way. All right, okay, so I understand what's going on. So yeah, I'm going to modify the point when I'm done. So you see that here it's the derivative is increasing, and then this is my inflection point. Actually, I could have done even a better job by computing this derivative there, but I don't know what it is. And then I know that this one, I've computed it, it's 0. And then this is nothing, so it's probably increasing. Okay, so hopefully it's not too bad. So now I got you agree with me. I have the right to check on Google whether I'm not too far or not. So you see what I did there. So I said this is an inflection point. So it means that the derivative is increasing, then decreasing. This is an inflection point. So the derivative is decreasing, then increasing. And I've drawn it like this should be even more like this. because here I know that the derivative is 0. We know that it's a critical point. Okay, so yeah, Google, my friend. Minus x squared divided by 2 plus thirds times x minus 1. Is that all right? Please not making a fool of me. Oh, yeah, okay. All right. Yeah, so the exact shape is hard. This point, I have no idea. Yeah, probably there are ways to find it, but it's not easy. And that too doesn't look like it's a nice point. So let's have the sketch and the final answer. Yeah, 2 was nothing. I just slipped my mind and I put it there. So kind of Google's answer. And my answer. Again, all I care about is that, oh yeah, please, this is kind of obvious, but still, I like when you show that which points they. Yeah, so I'm not going to put too much emphasis on friction points. So there's a decent chance you have some curve to draw, but it shouldn't be too messy, and I'm not going to ask too much of you. So don't be too scared. Okay. So that was, so any questions at home, any issue? No, nothing is written there. Sound is working. Yes. So if you ask me, how should I practice? Well, just write some expression, try to find the critical values, try to, and then check with Google whether you try to sketch it, check with Google whether you did a good job or not. So that's a decent exercise. Okay, so this we did. So that was E. Okay, so number 5. So now, how many people are there? 6, 7, 8, 9. How many people are registered in the class? Like 20 something. Anyway, so it's a nice subset of people who were here until the last moment and are going to benefit from this last session. Why? Because I was a bit lazy and I used the same material from last year's final exam in the homework assignment. So you might get some answers there. Yeah, I'm going to, but so it's different, but some of them are going to be useful. What is the gradient of U? Yeah, so anyways, it's a bit different. So you get the help you get. So yeah, let me just copy that. It's too long to write. Try first with N. Okay. Okay. So let me read it. Consumer consumes two goods, 1 and 2. Utility function is quasi-linear, so it's the same as in the homework assignment. It's where v of x of 1 is x1 is a positively sloped function. And of course, the quantities are at the least 0, but they have to be positive. Assume that the first derivative is 0 for no matter the value of x1, and the second derivative is smaller than 0 no matter the value of x1. Just with this information, we can say a lot of things about the nature of good 1 and good 2, as you're going to see. So A, what is the gradient of U for some bundle of good x1 and x2? So I think you had a similar question. Yeah. Yeah, it's. I'm going to try and see. Yeah. Yeah, thing is. Let me see. Yeah, this is in the assignment, you're right. If the consumer, I didn't think that I would be showing the solutions of this past the, still with the assignment going on, but consume the quantity of two, consume as much as good 1 as desire. Okay, so B is not there, but it's a stupid question anyways. So do it yourself. I'm going to pose the solutions. So B is a stupid question. So let's go ahead. If the consumer must consume a given quantity of good 2, but can consume as much good 1 as desire, how much would he choose to consume of good 1? Specify your answer. Um, so it so yeah, it's more defined by what consumers do. I didn't say what the consumer likes, but can you know more or less what do consumers try to do on this? Yes, they try to maximize their utility. And here, what did I say? I say that they have a given quantity of good 2, but they can consume as much good 1 as desired. So then how much good 1 would the consumer choose? Yes, so as much as it can, infinite amount. So here, essentially, what I'm saying is you don't have a constraint. So if I tell you you can consume as much as you can, then okay, you look at the utility function. So x2 is fixed. I don't have to care about the choice. And I look, okay, so what's going to make U as big as possible? Well, since v of x1 is positively sloped, then as I increase x1, 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 I always increase U. So let consumer maximize. So much as since there is no constraint.
This is a perfect complement, then that's not possible.
If they were perfect complement,
Yeah, not possible.
yeah, it's just it doesn't matter.
Okay.
So if they are perfect complement, it's like this. So if x2 is x1, so if x2 is there, so my utility is that one. So if I have an infinite quantity, it's just the same.
Okay. But for substitutes, like it, you gotta have a furnace.
Yeah, if substitute, I would go for it. Consume as much as possible. Okay, C. If the consumer has a budget, yeah, that's the thing. I have to give you some pointers. Anyways, I'm guessing most people have done it already, but yeah. Yeah, okay. Yeah, really, I didn't think that I would be in this situation. Okay, so yeah, let me skip that and go for the other exercises. This Taylor, we've already did that in class 2. So yeah, or I could just do 6A.
Is it possible? Maybe you
Oh yeah, yeah, yeah. Yeah, yeah, yeah. No, that's a great idea. So let's change that a bit. So not use a Cup Douglas. Okay, yeah, let's redo 5, but with so what I like about 5 is that I have some function with properties, and then you can just deduce anything with not knowing what V is. But yeah, I'm going to show the solutions for that after today. So let's do it again with another function. Yeah. So let's redo. Yeah. So what would be not too complicated and yeah, sometimes you get messy stuff. So if I just take ln x plus nxy, it's just like Douglas. Ln x. Oh, like you mean a specific function for f?
Yeah.
Plus?
Just replace the FX one with LMX.
Yeah, I'll have. So okay, it's going to look alike, but not entirely. All right, let's do that with a specific function. So what's the gradient? U for some bundle. Okay. So, well, of course, I just compute. So I have U equals to and then x1 plus then gradient. Oh yeah. So I take the partial derivative with respect to x1 equals to 1 over x1 plus 0. And the partial equals so the gradient is, I haven't specified any special number, so it's just all right, so this is how you find the gradient. So the derivative with respect to the first, the derivative with respect to the second. All right. Oh yeah, so C. If the consumer has a budget, show that he will consume such that well, it's going to be 1 over x1. So, are you sure? Because this is V of no, I think that it's going to this is going to be 1 over x1 equals p1 over p2.
Yeah.
Yeah. Oh, x1 is going to be yeah, okay, right, all right. Okay, so let's optimize. Let's start by substituting. That's first. The constraint. So I'm not saying that's the only way of doing it, but that one works. So x2 is that's equal to, yeah, let's do it. Yeah. And then anyhow, I did that like so many times, but every time I just have to make sure that I don't mess up. Okay, so this right, you have purely x1, which would be when I maximizing. First order condition. So this is 1 over x1. This there's no x1 there. 0. And as expected, we find or as you were suggesting, x1 goes to p2 or p. Yes, and of course, so v prime of x1 is 1 over x1. So if it works for any function that, yeah, so the thing is, we didn't choose log at random. We choose something that fits this bill there. So it's a positive valued function. So, well, it's, I mean, it's a positive derivative and the negative second derivative.
Also,
The what?
will also work.
Yeah, square root of x would have. Yeah. And also, of course, we always only take the positive values of x. So yes, square root works as well. All right, next one. So now, now I switch to p. So I try to check whether I make a mistake in this thing. Is sometimes I think that one thing is too difficult, so I remove it, and yeah. Better starting with too much and remove it. And so using the fact that the consumers show that good one is a ordinary good and a substitute of good two. All right. So I think that's all right. Yeah, okay, so I'm not revealing anything special. So it's still a challenge. The last question is still a challenge. Okay, so let's go ahead and do that. Show that good one is an ordinary good and a substitute of good two. So ordinary good. So what should I be showing there? So this is microeconomics. I know it's been a while. Do you somehow remember what it is? Yes. So I was really thinking that the students last time they had just learned what this is, and they were like, yeah, but we have no idea what these things are. So ordinary good is the elasticity is smaller than zero. So when the price goes up, the quantity consumed. So that's an ordinary good. So let's we have a solution for x1. So we don't have to care too much about the utility because anyways, not the utility, the elasticity. What matters is the derivative. So, so all we need to do is consume. Is check the first derivative. Yeah. Is okay. So price elasticity. This is a bit aside. You're not going to have elasticities in the exam, but still, price elasticity is this is equal to the times Q1 over X. And you could also have cross price elasticity. Yeah, exactly. So you would have 2 the x1 And by the way, we're going to need this for the next question.
Oh, yeah. Right.
Okay, so let's compute it. So now let's check that. So we have that dx1, dp2, dp1. So that's smaller than 0. So a good one is an ordinary. It means that when the price goes up, I consume less of it. And if I wanted the elasticity, then with this thing there, I couldn't say anything. I would just have to put back P1 over X1 because I don't have an explicit solution. Here I have an explicit solution, but if I just had V there, then I don't know what the value is. I just know the properties of the functions around it. Okay, second one is a substitute of good 2. So in that case, you would have d positive or negative. Yeah, exactly. So what does it mean to be a substitute? It means that it's something that I use when I cannot use the other. So in that case, when the price of the good 2 goes up, then I want to consume less of good 2, and I'm going to substitute to good 1. So let's do that. Okay, so the exam was not too crazy once you know what you have to do, but yeah, I was sure that the students had just done some microeconomics, so equals 2 minus 1. So it's oh yeah, it's plus. So it's greater than 0. So it is. And now F is it luxury good. All right. So for this, so luxury good is when income goes up. So that's more challenging. So consumption increases more than proportionally. Oh, so can we say something about this or not? I'm not sure. Maybe, maybe not. So it means that elasticity. Yeah. So usually I use eta. Eta 1 is dx1 m. Oh yeah, yeah. We can see it. All right. Must times x1. Yeah, so it's dx1 over x1 divided by dm over m is greater than 1. So that's what it means to grow more than proportional. So it means essentially that dx1 is equal to x1 over dm. Yeah. 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 So that's equal to equal. So essentially what you have to compute is the elasticity of income, elasticity of consumption with respect to income. And let's do that. So dx1 over dn equals to, so, and how do we know it's 0? Well, because we have an explicit solution. We know that x1 equals to p2 or p1, and it's equal to that no matter what the income is. Is it true? Well, no, because if I have an income of 0, then I'm not going to be able to consume p2 or p1. So the first order condition needs to be satisfied. But if they are, so since now here by doing this, we assume that we satisfy them. What do I mean by this? Is that I could, so let me just try and have this camera there. All right, so we can see what's going on. All right, so essentially what I'm saying there is if my first order conditions are satisfied, I'm going to consume somewhere around this. So this is what we mean by a quasi-linear. But if I don't have enough money, then I'm going to get to this point and then get this axis. So, but that's that we anytime we use a quasi-linear, we just assume that we're somewhere there.
But in this case, the same logic, like the same figure should work. Like this carry out, because I question that is like what I'm saying is that you can just carry out the same figure that we did for E and then check it. Because obviously one of it's not dependent on it.
Yeah. But so the thing is, if my good one is not dependent on income, then what happens if my income goes up?
It will affect your good too.
Exactly. So my good two is going to change. And okay, now I had some questions about the assignment. So the difficult question was the last question. So last question was the x2 dp1, something like that, right? Or dx2 dp2, I don't remember, but it's the impact of the other good. Yeah, maybe it was this. Yeah. Yeah.
Show that the elasticity equals P1.
Yeah, -1 or something. So what you have to realize is, well, it turns out that this is useless we don't have any x2 in this expression. So we have an other expression with x2 inside it. Yeah, somehow we have some x2s, so they come from somewhere. So we can use this, but we have to be aware. So yeah, to do it. Use both the first order condition and the budget constraint and note if to change, then probably x2, x1 and x2 may change. So be aware of that. And then otherwise, not otherwise, but after that, some algebra. And you should find, maybe I made a mistake. So maybe everybody's struggling because you cannot show it. So that's the risk when I say demonstrate this. I assume it can be done, but maybe it can. We'll see. All right, so that's it for this. Taylor, we have already done this. Hmm. Yeah, so we already did it. So we have like 4 minutes. So just why don't you, if you can, if you have your phones or computers, go on Moodle. Uh, oh yeah, that's always fun. Please sign me in. Oh yeah, I don't think, yeah, I think we won't have time to do it. Anyways, so okay, so on Moodle, I have posted a lot of, so I can show them. Anyways. So please don't look at, okay, I'm going to, please don't look at who's calling me. Because yeah, the security requires me to check my phone. All right, so one other thing that I suggest you do to prepare is, of course, you can check again the labs, but check these quizzes. One is yeah, rational roots, multi-market equilibrium. This is yeah prior to the midterm, matrix notification, matrix properties. So if you hadn't realized, I have posted them there. Total, yeah, that one is. I remember last time students found it challenging. So it's a neat exercise on total derivatives, just yeah, computing derivatives. So you have logs there. Oh, I think maybe we did something similar in class. Is that possible? Yeah. Okay, so what I suggest is change it somehow and practice computing total derivatives. Do I have some other there? Optimization. Yeah, so perfect competition produces a quantity y, so that price p equals 8. What's the profit function in this situation? Looks like I haven't given any profit function. So the quantity y, so that equals 8 as, oh yeah, production cost. Oh, okay, all you need is the production cost. Okay, that works. Find a quantity. So I suggest you practice with these things too. So they're there to practice. Plus, yeah, otherwise, mail me if you have questions. And, so otherwise, so that's it. Yeah. This one.
Yeah, the notes that I specifically the program.
Oh, yeah, I better download it. That one?
Yeah. Well,
All right.
I'll ask you after the data.
All right. Well, it's kind of, yeah, it's finished. Right?
Yeah.
Yeah, so well, good luck. Ask me questions, and it was fun teaching. So best of luck for that.